Okay, good evening, everybody, and welcome to this session. And normally we start this session at sharp 7 o'clock because we do not want to penalize the people who had come early, okay, on right time. So, so it's better to be at the right time here. That we maintain the timing very clearly, and same way we close it at 8 o'clock. Okay, so on behalf of Eastern Academy. That is, Eastern Academy is called Electrical, Computers, Electronics, Networking. That's these four are the today interlinked. That's why we call it as a ESAN. Okay, so ECEN. And today's session is going to be of introducing the networking concepts. My name is Balaji Sheshadri. My WhatsApp number is 90429 14720. Please make sure you add this in the contact list because I do not create a group. I created only a broadcast group. In that case, only if you are in my contact list, my message will come to you. But when you send a message, it will come to me only, not the group. It will be one-to-one communication. So it will enable you to ask any question. Okay. So sometimes people ask me, sir, I have 5 years experience. How do I get a job opportunity in networking? So many things. So try to avoid too much, but it's fine. Sometime you can ask me. If I have expertise, I will help you out. So nothing to be only on specific to this 5 days class. I mean, right. So make sure that you communicate to the WhatsApp. Don't go to the next class. Anyhow, at the end of the class, by about 10 o'clock, okay, worst case, we will give you the recorded session of every day. Okay, there'll be a link given on the first day. The same link can be used to all the days, okay, to see the recorded version. So if you have any doubt on this, you can go back and watch the recording session and get me the doubt tomorrow. Okay, so that's a thing we have advantage here. And you can ask me. You do not wait for next day also. Immediately you can ask me on the WhatsApp. Okay, which is always there for you to help anytime. Okay, so we are trying to help you out anyway. Ultimately, I wanted your networking concept have to be very, very clear. So all the top level networking protocols, so many things are going today, IoT and everything. But below that, what is at the bottom, which below that TCP/IP or socket layer, what is exactly happening? We have so many things, wireless, 4G, 5G, and so many things. And then what's all happening exactly at bottom layer. Okay, so we need to understand them very clearly. That's why we have a session today. So we thought we will complete it at 5 days. Okay, if it is not, I'll give you some recorded material in between to watch you. So let us start the day today. And we have how many of us there today? It's about 40 people are there. It's very good. So we start with 40. So about 2/3 of them are, I think, joined. I think. Let us see. I hope somebody will call exactly at this time. Sorry, not able to connect. Okay, no, it's not. Okay, so let us start the session. It's a very, very simple. For networks, basic essential is called communication. So that's why we start from data communication. Okay, that's the first day. And the second one is we call them as network types. And third day, we are going to talk about a lot of you will know about MAC and IP address. We'll explain very clearly. See, I'm not trying to give a topic which you don't know. Please understand. You all know these topics very well. Okay, but everywhere there is some small gap in the understanding. That is what I'm trying to fulfill. See, I'm not trying to say that, oh, I'm digging from the scratch and give you everything. No. So that's also possible. Somebody who does not know anything about network also will learn it from here. But I know that a lot of people studied about networking. So what I'm trying to give you is some very, very important details which you missed in the college or in the industry somewhere. That will be very useful. That is because I lived with 34 years on networking. I've started in my 87 when I joined HCL R&D as a R&D engineer. My first project was X.25 communication project. I designed the hardware with the communication project. My last two projects was, one of them is about 100 gigabit Ethernet, and the other one is about autonomous car project. So where I have to write driver. So I lived with this 34 years only on the networking projects, lot of things. So even though I'm an embedded engineer, I've spent a lot of time in the networking. Bottom layer. See, networking you have two versions. One is bottom, one is top. So top layer you get everywhere, but the only thing is bottom layer I'm trying to reveal all the hidden truths. Okay, so let us start from communication. So before data communication, let us start about communication. Okay, that's why the day one we start about data communication. So what is actually communication? I have a person one, somebody, and I have another person. There are two people are there. So when person one talks and person two listen. Okay, now let's take a very unique case where person one can talk, person two can listen, but person two cannot talk. Assume a case. Okay, this communication, that is a one way. That is, a person one can talk to person two. This communication is called simplex. It's a normal. I speak, you listen. Okay, we'll discuss about all the other things later. That is, I speak in Tamil and you speak in you understand only Telugu or Hindi. What will happen? Those things we'll discuss later. Right now we don't. Right now we are assuming that you and me both having a same language. Let us not worry about too much on the languages. Okay, then same thing. If I have a person one and person two, if person two talk to only person one, not person one to person two, then also we call simple. That is, so this is also called one-way communication. So please understand, these are all going to be applied on your data communications in electronics. Okay, in computers, whatever it is. So it's all electronics only. So the advantage of both electronics and data communication joined together, doing a miracle today. Okay, that's why we could be able to control from sitting in Earth and some objects in the Mars. We do that, everything. So everything, all satellites, everything is going to be controlled by sitting here. All digital money, everything all based on this. So we need to be very thoroughly understood. See, we know it, but we should be thorough. Don't leave it the 5 days without understanding thoroughly. You should be very comfortable. That means that at the end of 5 days, whatever I discuss with you, you should be able to deliver a talk to somebody. If you can able to comfort that level, that is what I exactly wanted. That's why I'm trying to explain things as simple as possible. Okay, I'm not a PowerPoint guy. I will go away from PowerPoint to a board after some time. When I'm trying to express my concepts, which I've spent so many years, I cannot sit and do the animations. I don't have such amount of patience. So then I'll get into the board. Board is I lived with the board for 34 years. So I cannot just take that, leave the board. Okay, now let us see the next case where our typical case. See that I have two arrows. That is, person one can talk to person two. Person two can talk to two. See, let's say you and me are meeting each other. I can talk to you, you can talk to me. But just understand one thing. Normally, what we don't do here is, when I talk, you don't talk. Am I right? So this is called duplex. Both of them can talk. Okay. So there are two terminologies I've introduced. One is called simplex. One is called duplex. This is all about communication. Now, the same thing, the duplex, they're all fine. But one small thing now. When person two talk to person one cannot talk to two. That's not possible. When I'm talking, you are hearing. You cannot talk. If you talk and I talk, we both talk, then there'll be a confusion. It's not possible. That's why normally you see that all the police everywhere, cop and all will have a wireless say over. Then the other person will speak. So where this is called duplex, that means there's only one wire, one media. Like now we have only one air. Air is a media. If I talk and you talk, then there'll be both the sound wave will get mixed up there. That's why we always say that one person talk now, or I talk. Person one can talk to person two. This is called off duplex. So in duplex itself, one is called off duplex. Now there is one more case where, because we have to thoroughly understand what it is, that would be very good. Now person two can talk to one, and simultaneously person one can talk to two. This is called full duplex. That means, let us take a case. My mouth, I have a small device on my mouth which is connected to only your ears. So it means that when I speak, the air does not go anywhere. It goes through the tube only to your ears. And from your mouth, it is connected to my ears. Then we too, when I am talking, you can also talk. That is what here. There'll be two wires will be there when you do the full duplex. When I do same duplex, when I do off duplex, I had only one wire, off duplex case. Whereas in off duplex, both can talk, but only one wire. Whereas in a full duplex, you need to have two wires. Please understand, this is a very important. If you do full duplex or off duplex, for example, day to day we are using USB. USB is off duplex. You know that USB is off duplex. And we know that all along the way we are using Ethernet. Ethernet start with off duplex, and today it is a full duplex. What is the thing we'll tell you? And you would have heard a device called hub and switch. Ethernet hub, Ethernet switch. Ethernet hub is off duplex switch device. Ethernet switch is a full duplex device. We'll discuss what is the advantage, because these things will give you lot understanding about electronics, that somebody will call about bandwidth. Which is better? Single wire communication or multi-wire communication? What it is? Okay, these are all we'll discuss. That we will discuss tomorrow. Before that, we will discuss another very important point today about communication. Am I right? Okay. After this communication, okay, then comes to the point. It's called network, where I have multiple people talking together. We are forming a small network. Am I right? So we have about 5 people joined together in a class group. This is called a network. So how do we communicate within these people? That we see. First, we are going to discuss point to point. Once we understand that, then we are going to discuss how do we going to communicate within this group. Okay, that's within the network. Then the next level of concept is internetwork. That is, I have so many networks, I connect all of them. Okay, network 1, network 2, network 3, network 4. There are so many people, we connect all of them. Am I right? So how do we connect all these things? That means that there is one more trick is there in this. That is very critical. That is, I written everywhere P1, P2, P3, P4, P5. That means that you think that every network, you go to the previous slide also. You think here, there are about 5 people are there. When I wrote here, in this communication, there are only, when I say person 1 and person 2, you think that there are only 2 people are there. Okay, let us assume I have 2 computers, I connect them through wires. You think you're connecting only 2 computers. Actually, it is not. That is a confusion. The major confusion is only that we will go in depth. That is actually when I am not connecting now 2 persons. No. That's a trick. Everything physically you do is only connecting 2 persons. But logically, each person have hundreds of persons in him. That how do we communicate? Maybe I'm not, I don't want to confuse now. I'll confuse this on the 4th day. That's correct. 4th day is the right day to confuse you. Okay, but till that time you wait. So that is, when you say here, see a person, it is not one person. Within him, there were a lot of people are there. That I'll explain the thing. Now let us go to the board. Okay, so if you have any doubt on so far what we discussed, before I go to the board, If you have anything, you can ask me. You can always, anytime you can chat me. Then nobody stops you from coming to the chat. Okay. See, I'm not running a very formal site of class or anything. Anytime, if you find you don't understand, then come to this one. Okay. Okay. So now let me go back to my professional way of doing things. It's not everybody's professional way is PowerPoint. My professional way is board. Okay. So let me get into the board. Board is a very simple. Before that, I'll wanted to tell you one thing in the PowerPoint itself. We discussed about networking. This is what I'm expecting from you. Everybody will say prerequisite. Am I right? Before you start learning anything new, let us say you try to understand subtraction, you should know addition. Try to understand multiplication, you should know addition. Try to understand algebra, you should know addition, multiplication, everything. Like that. To learn the networking, if you know this concept, understand, if you know this concept, that is a switch and a bulb. When I put the switch on, the bulb will be on. Okay. Am I right? So switch is on, the bulb is on. Otherwise, when the switch is off, bulb is off. If you know this, that's sufficient for next 5 days to understand. The only thing is, if you think the network is going to be complex, I cannot understand. If you have a mental block, I cannot do anything. But I am expecting you to understand only this: a switch and a bulb. That's all. And switch on means bulb is on. Switch on off means bulb is off. Okay. That's what I exactly wanted. Okay. Now with that, let me go to the board, because I told you already, I'm very okay. So what we have left is there is a communication. There are two people here, person one and person two. There are two people. They are trying to communicate through a wire. Normally, in our case, we use a air. We use mouth and ears. Mouth and ears. So I speak my mouth, you listen to on ears, and you mouth on ears. But only thing is, as I mentioned to you, that you cannot do this in simultaneously. That is not possible. If you do it simultaneously, then what will happen? There'll be a confusion. That's why we always talk only one at a time. Now let us assume that the person one and the person two, we are going to start with electrical, not with mechanical. Those days it's possible. People communicate using mechanical device or sound or anything. Right now, no. We have directly jumped into electrical. The easiest way is I have a wire. Then I have a battery. Let us assume this is a 5 volt. Then I have a bulb. So this is person one and this is person two. Person one is having a switch. Now think of it. In this case, how do I communicate? That's a big trick. There are two types of communication on this place. That is, I only have a wire and there is a big, let's say this is a room. This is room one. This is room two. Room one and room two. There are two rooms. Okay. So how do I tell him, come to my room? But that P2 is watching the bulb. Okay. P1 is having a switch. It's quite simple. I told him very clearly. Hey, I put the switch on. If the bulb glows, come to my room. See that? I told the person P2. Now let's assume that P1 is a master and P2 is doing some service to P1. P1, I've told to P2 only one. Yeah, you do only one task. If the bulb glows, then come to my room. Okay. That's it. So what the P2 will, he'll be watching the bulb. He will do it. Am I right? Then he said that the P2, I want to do multiple tasks. Then they have come out with a very good idea. The idea was very simple. This guy, instead of a switch, he put a regulator. Understand? He put a regulator, like a fan regulator. He put a regulator. What he told him was, hey, if it is bright, then come to my room. If it is a little bit dim, let's say I have a 4 level of bright, and I have a in between 2 level. Okay. If it is this much bright, less bright, then you go and lock the door. Okay. Then if it is still lesser bright, understand now, there is an understanding between person P1 and P2. P1 is initially what happened, this guy had only a switch. When he had a switch, he could convey only either come to my room or don't come. He could convey only 2 work. One, okay, you sit ideal or come to my room. There are only two tasks. Now, what I have done was very simple. What I have done was very simple. I removed the switch because the switch means only on or off. So I put the regulator. Regulator is a very, very good thing. Am I right? So I can why we are using a regulator for fan? I can control at any level of fan. Okay, whatever speed I want, I can do that. That is the advantage. They also used it. But unfortunately, there's one big problem happened. What happened? When they started moving the more brightness here, okay, due to the wire, I put at one position. I am thinking that I am digging, let's say 0, 1, 2, 3, 4, 5, 6 levels. Assume there are 6 levels. Let us say I am thinking that you have a fan. Your fan is having 6 speeds. Now the same thing here. The bulb is going to have a 6 brightness. I am thinking that I am putting it the 3rd position. The bulb will go on this bright. Then he will do some job. That is, go to the shop and buy something as per the agreement. But unfortunately, because of the wire, okay, because of some issue with this voltage, so many issues. I put the position at 3, but unfortunately, the bulb is glowing only at 2 level. So I am thinking that he is going to do the 3rd job. But what he is going to do now? 2nd job. This is a major problem in this type of using regulator in electrical. This is called this type of communication from P1 to P1. We call it as a analog communication. Analog communication. One advantage is I need only one regulator, only one wire. I can transmit any number of levels. Whereas when I had a switch means I can do either on or off, only two level. Switch means only two level. But when I have a regulator, I am going to have a n number of levels. That depends on your sensitivity. Provided whatever voltage I am giving here, that goes here. Whatever I expect the bulb to be on, if that bulb also on there, it is fine. But unfortunately, that does not happen. That's the reason in the colleges, they teach you so many things. That is called, now I'm not going to touch that, but I'm going to tell you the thing. What they do here is, they will take this brightness, the voltage, give it back here. Based on that, I will increase it. This is called feedback. Most of us get confused with the feedback. The feedback concept is very simple. The feedback concept is, let us assume very simple case. I am sending him 6 volts, thinking that that guy will be receiving 6 volt. So I want him to get 6 volt. I am sending to the regulator. I am sending 6 volt. My supply is, let's say, 10 volt. So I'm using regulator and giving 6 volt, thinking that that guy gets 6 volt, but he's not getting. So what happened? That guy is giving a feedback and telling me that I am getting only 5 volt. See that? He is giving me, he's getting how much? 5 volt. But I want him to get 6 volt. What I do now is, I will change the regulator to 7 volt. When I increase it to 7 volt, he will get how many voltage? 6 volt. Because there is a loss here. That increasing to the thing is called feedback. Okay, that's why the big confusion in the analog electronics discussion. Most of the students, whether it's called, see, you could have heard something called regulator. Am I right? What regulator does? It's doing nothing. Let's say that you want the output to be 5 volt. You want the output to be 5 volt. The input is getting 9 volt. If you get 4.5, then the feedback goes, and this guy makes sure that you get 5 volt. So the feedback mechanism makes sure that this is all very complex. That's why people normally don't like this analog communication, whereas they like the very simple one. A switch, bulb. A switch and a bulb communication. A switch and a bulb communication is the easiest communication, where advantage is this is on or off. By chance, I'm applying here 5 volt. If it goes here 4 volt, still the bulb will be on. Okay, instead we go to 3 volts, still the bulb will be on. You don't have to worry about what is going to happen in the line. Okay, so because of this, they love this digital communication. But unfortunately, that's why people I'll explain later of time permits. Maybe at the end of final days, I'll explain where analog is used. Still analog is there, but how it is used. But entire world is digital, where analog is used. We'll discuss about that. Then people thought they have an understanding, very nice understanding. What they have done was added one more switch. Am I right? I have 2 switches, 2 bulbs. Am I right? It's very simple. This is called green, red. There's a possibility, green and red. Am I right? Now, what are the possibility? Both can be off. Or red can be off, green can be on. Red is on, green is off. Both are on. You get about how many combination? 4 combination. That you get about 1, 2, 3, 4 combinations you have. Now, with the help of 2 switches, with the 2 wires, I can give him 4 job. If you want to give him more than 4 job, okay, then I have to add 1 more wire. In this case, 3 switches. I'll have 0, 0, 0 to 1, 1, 1. That is 2 power 3. I get about 8 combinations I have. Understood? So every time you want, see, if you want to have more than 8, I have to add one more wire. If you add one more wire also, I'll go up to 16. If you can't have more than 16, then I have to add one more wire. So based on that, if you keep on adding number of wires between two places. So I have A and B. Between A and B, I keep on adding number of wires. 1, 2, 3, 4. So if I add 6 wires, 2 power 6, I can communicate up to 64 commands, not more than that. Okay, it could be anything. See, what I'm communicating is different. Okay, so what we have is every number represents one job, one work, which he is having a table 1 to 100. Okay, but unfortunately, with the help of 6 wires, I cannot go. If you want to have 100, then I add one more wire. So these people thought, hey, this is quite good, man, because using a switch, nothing happens. If you on means on, off means off. That does not go below that, because a bulb is on means it's a bright or dim, bulb is on. That's an advantage with digital. That's why it's become very powerful worldwide. Whereas the problem with the analog is, you think that you are giving him some brightness, but the other guy received will be different. But the advantage is, I don't need, if you want to have 100 numbers, then I can use only one wire. In analog, which is possible by one wire, in digital, I require 7 wires. But the trick is that there's a 2 problem happens. The thing is that one is cheap. Analog is cheap because one wire. But second one is reliability. Now, when it comes to transferring the number from one place to other place, what is happening is digital has got better reliability than analog. That's why what happened, if you take an old tape in 1960s, 70s tape, if you take, you may be having your house MS Subbulakshmi tape, but if you today put it on the tape recorder, that's gone. Okay, but in the digital world, if somebody records a song, it comes through to you through net anywhere, but you hear it, it becomes so perfect. That's the advantage of digital, where the reliability is fine. The drawback with the analog is its reliability, but advantage analog is one wire can carry multiple levels of signal. Now, next thing is, how do I avoid? I know that I want reliability. I know I cannot compromise the quality. That is, I cannot compromise the reliability. So I decided to go to digital. But the trick is, how do I reduce the costs? Then people have thought, come out with an easy solution. I have one wire only, one switch only. Okay, one wire and one switch. I know that there's a switch. This is A, this is B. When I press the switch, it's going to be on. Am I right? When I press it, it's going to be on. When I release it, it's going to be off. This is what we need all along the way, 5 days. Okay. Now, what happened? How do I convey a number 25 to him? So easiest way is, I press the switch 25 times. That's why people are doing initially. 25 times they were doing it initially. Or if I want to send 65, I press the switch 65 times. But if I type for one time, if I press and release, if it is going to be 1 second. To send a number, I will take how much time? 65 seconds. So to convey one number from person A to person B, It will take about how much number? 65 seconds. Then people thought, how do I reduce it? How do I reduce it? Okay. So the trick is that they have found a nice method. The method is very simple. I will convert this number into binary. Let's assume that's 65. That means that I'll get a number. We'll take some number 0, 1, 0, 0. Could you get it how it is? 1, 2, 4, 8, 16, 32, 64, 128. This is a binary numbering. Like we have a 110 everything. So what happened? I convert this number. Let us take any binary number. Let us take a very vague binary number. Then we'll come to this number. Let's say I want to transmit 0, 1, 0, 1, 0, 1, 0, 1. Let us take this number. Now what happened? This guy having a switch. This guy is having a bulb. Now it's very good. Happened. What happened? I press the switch. The bulb is going to be on. Oh, this X person, he watches A. A person watches the bulb 1. He presses the switch. This bulb goes. This guy return 1. Fine. Now what happened? B. Now A is once again put, bulb is off because 0. This guy put 0. Then A is once again on. Then bulb is on 1. Then his guy off 0. So this guy could be able to convert this number 1, 2, 4, 8, 16, 32, 64. If you add them, 80, 84, 85. So he conveyed the number 85 to him. So when there is an on means we assume bulb is on 1, off means 0. Okay, this is the way I convert. But normally when I talk to you and you talk to me, this all voice are all analog. They are not digital because there's only one wire. But that's the way the whole real world is analog. But whereas in our world, we found a mechanism to do it through everything on digital because switch is more reliable. Your brain is having when so many people speak, a noise comes, your brain will filter and take only your voice. Even a big crowd, if a kid hears only his mom's voice, it will understand. How could it possible when such a big crowd? We don't know. We don't know how your brain is doing such a powerful thing. But in electronics, which is a very beginning stage, these are the problem people faced. But today we are in advance. Fine. That we'll discuss as a call. You could hear it everywhere. We are called echo cancellation and noise thing and everything. They're all fine. That's all because of a field called DSP. Very powerful field, which does the wonderful thing. Let us not go and try. If you go there, it will get deviate. Now our job is, how do I communicate a number from place A, person A to person B? So person A is having a switch. Person B is having a bulb. He has to transfer a number 01010101. What is happening? He is press release. He is happy. Now suddenly our man wants to send a different number. He wants to send this number. What he will do? He wants to transmit this number to him, convey him. Now this number is value is 1, 2, 4, 8, 16, 32, 64. 64 plus 16 is 80. 80 plus 1, 81. Our man want to transfer, what is the number? 81. So he on the switch, as usual. Our person on the switch. 1, on the switch. Our man put what number? 1. Good, everything is fine. Then he off the switch. Our man put 0. Then next one is he off the switch. Switch is still off. So our man put 0 only. 0, 0. Now you on the switch. Then you put on. Bulb is on. So he put 1. Then you put 0 off. You put 1. Am I right? So you send number 0 1 0 1 0 0 0 1. But what our man got was 0 1 0 1 0 1. That means that 1 2 4 8 16 32. So he got 21. What number you transmitted? 81. What is the problem here? The problem here is you transmitted the 3 zeros. You don't know how to do that. Our man got everything as a bulb is off. So they had this is another very critical information. This is what most of the people get confused. That's a thing. How exactly this information came. They had an agreement. The agreement is when I on the switch afterwards, I will pass this on or off every second, not like this 3 seconds. I will, if a bulb is off for 3, see, now I see here, what will I do? The person A, if he has to transmit 0, 1, 0, 1, 0, 0, 0, 1, what he will do, he will put on for 1 second. Then he will off for 1 second. Then off for 1 second. Off for 1 second. On for 1 second. Off for 1 second. On for 1 second. Off for 1 second. That means that he takes how many seconds? 8 seconds. He takes 8 seconds. Whereas this man, he is looking at thing. Okay. Oh, bulb is on. First second. He put 1. Then bulb is off. For how many seconds? 1 second. He put 0. Next second, bulb is 1 second off. Bulb is on 1 second. 0. Then on. So what is happening? By having the agreement of timing, the person who transmit the data and the person receive data become perfect. Okay. This is a very, very important thing, because if you do not match the timing, let us assume that you are doing it every 1 second. I am doing it every half a second. What happens? Your data is this. Am I right? Your data is 1. Now, first second, you make it on. For how many seconds? 1 second. But for his timing is half a second. Since he sees that bulb is on for 1 second, he put 1 1. You transmitted what? 1. Because you on the bulb for 1 second. But our man saying, because 1 second, his timing is different. We both are not given the same timing. So we don't have agreement. You do every 1 second. I see the bulb every half a second. So what happened? Now 1 second this bulb is on. I take 1 1. Then you transmitted 6 zeros. So I took 0 0 0 0 0 0. Done. You transmitted this number. I take 3. That is the reason. It is very, very important. We should not violate the agreement. Suppose it's not even this. The problem is this. Sometimes the 1 second become 0.9 second. 0.9 second. That time what happened? Initially it will be fine. You put 1, 0, 0, everything. But everywhere 0.1 second delay. So here 0.1 second. Here, when you start transmitting more time, slowly that gap will widening, and finally you'll get wrong data. So it has to be almost as possible equal. This has to be almost 1 second. Both. That is what timing. Now the next problem is this. See, I am trying to give some information, some data from person 1 to person 2. I use so many terminologies. I'll explain everything. What is information? What is data? Okay, everything. Commands or whatever it is, fine. Everything's all the same. Don't get confused. There's a small difference. Now what happened? I ask him to give some command. Each command is number 1 to 100. I want to transfer a number from place P1 to P2. That's what I'm trying to do. I'm trying to achieve it through the switch and bulb, because instead of switch, there are only 2. See, please understand why I did not discuss this more was there are only 2. We know that one is switch, one is regulator. There's nothing more than that. And we discussed that why I cannot use regulator, because it is not reliable. If I do anything, it will go other side, it's not. So I have to use only switch. That is what I told you in the beginning of the talk. If you know how to use the switch, you learn this whole thing. Okay, please give me a time. I'll explain to you that why I am discussing this, because we people have lots of confusion. What is happening? In this case, it's a wire. I can use wireless, or I can use optical. Okay, what is the difference? Now, wireless, there are so many things. You would have heard so many things. Bluetooth. Somebody say Wi-Fi. Somebody say cellular. Okay, there are so many things. What are all these things? That if you want to know, if you want to understand all those things, what I'm discussing right now is very, very important. That's why I am getting into the very basics of transferring a number from one place to other place, because using a switch, I can transmit either 0 or 1. I cannot do anything else. And I also discuss with you two possibilities. I can add multiple wires, but that is not feasible, because every house I cannot run so many wires. When I do so many wires, then it becomes very expensive. So I wanted to achieve everything through only one wire. When I'm trying to achieve only one wire, we found a mechanism where first I do switch so many times. That is too slow. Then we found a mechanism where I'll convert the number, let us say 85, to binary 0101 0101. That is fine. But because on, off, this is very nice. But on, off is you can easily write a number. But suddenly I want to transmit 81. When I want to transmit 81, it becomes 001. When I try to transmit the number, then see 3 zeros, how do I tell him? Then we had an agreement. Let us have a 1 second agreement. I take 8 seconds. That guy also took 8 seconds. So every second he'll be watching. That is fine. Suddenly our man wants to transmit 80. What he want to transmit? 80. 80 means what? This. Okay. Now what is happening? Our man, the P2. The P2 is watching the bulb. When P2 is watching the bulb, you put the switch off for 4 times. That means that this guy bulb is off. He will not write anything because bulb is off. Now you put bulb is on for the 1. He put 1. Then you put off 0. Then you put on 1. You put 0. Now what happened? You transmitted 80. Our man got 1, 2, 4, 0, 5. Gone. Then people thought even 1 second is fine. But unfortunately, initially bulb is off. He could not do anything. Then they had an agreement. Then they had a different agreement. This is the way there are so many agreements that came. And finally, we call that as a protocol or standard. Now I'm explaining you that how the standard came. How people are creating a standard. So if you understand once, then discussing about later things of networking are very, very easy, because that is becoming very complex because you don't understand this. You think it's a black box. Now what I'm trying to do is that this is not a black box. This is as simple as this. Now, what I'm doing now is, here is, I have an agreement. Previously agreement is 1 second. Every 1 second is data. Now I have agreement between P2 and P1. I will always, before I start sending you any information, I will on the switch. I will on the switch. Understand? I will on the switch. So our man was sleeping here. Our man was watching the bulb. Nothing is coming. What is happening is, I make the bulb on for 1 second. Both of them knows that there is a waste. That 1 second is going to be wake up call. Then that guy get alert. Hey, bulb is on, man. I have to start watching. Then he start watching the bulb. Then what I do here, this is 1 second. So the first second he will not write. That's a trick. When I make the bulb on first time, then the person P2 knows that it is a wake-up call. That is not any data. That is not any number. So wake-up call, he will not write down. But afterwards, after 1 second, next second, what is that? Bulb is going to be off because 0, 0, 0, 0, 1, 0, 1, 0. But I told you, no, this guy could be 1 second, that guy could be 0.9 second sometime. So they had a small another agreement. What the agreement was, when I finish all the 8, I will make the switch off always. That means that this should be 0. Starting should be you should get initially 1, then ending should be 0. By mistake, if you don't get 0 after 8, that means that guy will not accept that something is wrong. He will say that you will know that something is wrong. Okay, so you will find out what is a mistake. So there are 3 things we discussed. One of them is speed at which we communicate. That is 1 second. Every bit I am transmitting at every second. So if I have a 8 bit means 8 seconds. But now I'm adding 1 for initially, 1 at the end. Since I am starting with this, they call this as a start bit. And this they called as a stop bit. This is the, what do you call, start of networking. This particular thing, what I am telling you, lived in the industry for so many years. Even today it is that. This is what you are calling it as a UART communication. You are calling it as a UART. Everywhere you will say that SPI, I2C something, you will hear something else UART. Okay, today most of the embedded system, most of the microcontrollers, old microcontrollers, we are programming is through UART. Everywhere we have a UART. Okay, even a Bluetooth, it gives you UART. So many things. We'll discuss about later. What is UART and what we'll discuss later. Now, you understand this. That means that I have MSB can never be 0 because this is called MSB or LSB you're calling. Okay, so what is the thing is that when I am doing it, this guy is initially wire is nothing, bulb is off. Initially switch is off. Initially switch is off and nothing is getting transmitted. So the bulb is going to be off initially. But when I wanted to send something, our man is watching the P2 is watching the bulb. Now what I'm doing, I am putting the switch on. That time the bulb is going to glow. But he knows, because we have agreement, this guy knows that the first bit is a start bit. That is, he will not write it down. Then after 8 seconds, he will calculate the thing. Let us assume that I'm transferring this number, 110 thing. But unfortunately, our man timing, my timing is 1 second. Our man timing is 0.8 second. Our man is faster. So what happened? We transmit 8 bits. Okay. But since he is faster, he will get into the 1 itself for more time. So what happened? He will take 1 0 0 0 0 1 0 1 1. That is fine. But unfortunately, he is faster. This 1 will take it also for him because 0.8 into 1 2 3 4 5 6 7 8 9 10. It's about 8 seconds. Okay, understand? He is transferring it 8 seconds. But you took how many seconds? 10 seconds. So there is a problem between you and him. Whatever you transmitted in 8 seconds, he will take it as a stop bit. But our agreement is stop bit has to be 0. But he is getting as a, so after 8 bits, I supposed to get 0. If I get 1, that guy will have a buzzer. That guy will get a buzzer. He will press the buzzer telling that, hey, something is wrong, man. Then you have to find out, tune the clock correctly. In the exact system, this is called framing error. That means that I don't get the data properly. I don't get the data properly. It is, so we need to have a timing should be Yeah, bulb is default is 0. Yeah, always 0. That's what we say that by default condition we assume bulb is 0 condition. So when nothing is happening, this guy is not giving any data there, he will keep the bulb off, nothing else. Only when I'm trying to send, I will do the start bit and doing it. So this has to be very, very clear. If it is not clear, please watch this video. Anyhow, I'm going to give the recorded video, so you will be able to see it once again. And otherwise, I'll do some other mechanism. You can come to me on a chat. I'll explain. And now you can watch it. See, once you hear the lecture, things will be very clear to you. So I have 3 agreements. One agreement is speed. Second is start. Third one is stop. So to send 8-bit, I transmit one start, one stop. That is fine. But there's another problem came. That's the biggest problem. The thing is, due to some problem in the line, you have a AC at home, somewhere somebody is owning some signal. I am putting the switch on. Okay, due to some noise. Okay, due to some noise, the bulb is not on. I am thinking that I am transmitting 0 1 0 0 0 1 0 1. Okay, I am telling this, but that guy don't receive that. What will happen? Due to some problem, when I am transmitting this one, I am putting the switch on. Due to some noise on the wire, that bulb is not on. Then that guy will take it as a 0. You transmit as this number. Our man received as a 0 0 0 0 0 1 0 1. Understand? There is a error. Here he is not. His start bit is okay, stop bit is okay, but the data is wrong. I transmitted. I told you, digital has to be reliable. But in digital, if there's one bit is lost, what will I do? Then people have come to a conclusion. Let us do one thing, man. Let us not transmit 8 bits. We will transmit only 7. We will take how many bits? 7 bits. But there's an agreement. Both the person A and B have an agreement. The agreement is the number of ones here will be odd. Number of ones will become odd. Okay. Now, how many ones are there? 1, 1, 1, 3 of them. So I will add 0. So I make sure that I transmit the odd number of ones. So he also received this odd number of ones. But by mistake, while I am transmitting, due to some noise, I transmit this data, he receives this. What is the agreement? Number of ones has to be odd. Okay. But what is happening now here? Number of ones are not odd. So this guy will not accept the data. Do you understand this or not? This is a fourth one. First we thought speed, then start, stop, and fourth one is called check. Check whether what I am transmitting, or receiving it or not. Now I transmit 0 1 0 0 0. We have an agreement. The agreement is I always send odd number of ones. For example, you are trying to transmit this data. You are trying to transmit this data. How many ones are there? 1 1 1 even. So what happened? I will add one here. So the last bit is not data. It is only for checking. Actual data is how many bits now? They reduce from 8 to 7. Same way, while receiving, this guy checks all the ones. Fine, man. But when he receives the data, he checks 1, 2, 3, 4, 5 is odd. But he will not use this. So now what happened? I don't use start bit. I don't this check bit. We can call this as a check bit. Okay, the agreement could be anything. Agreement could be odd or even, or let's assume that, hey, I'm very clear, man. I'm having a very perfect line. I don't see any error at all. So I do not waste one bit. In that case, I can say that I don't want no check. There are possibilities called odd check, even check, or no check. See, this is what I'm trying to explain is a very, very fundamental things where how when you go to the word browser www.google.com, how exactly it's going on the wire. How from your keyboard you type, it goes to the bottom level. That bottom level is a very lower level of networking. Once you understand that thoroughly, once you understand that how the switch is working, what is router, all those things, then you can start configuring everything. They're all very easy. Okay, but I'm trying to explain about within 5 hours. Okay, understand, 5 hours only. 5 days summa. Okay, every day only 1 hour. Within 5 hours, I'm trying to explain that what is this, why I'm giving in between 1 hour, 24 hours. I could have a Sunday continuously 5 hours. Why I'm giving the 1 day is you can go and watch the videos once again. Okay, that's why I don't have more than 1 hour's lectures, because you should be able to watch and clarify that. That's a trick of this. So this check is called, they call it the parity bit. So to transmit 8-bit, 7-bit data, I transmit one start, one parity, that is check, one stop. In spite of all these things, so only 70%. Okay, only 70% is used. Okay, so I'm wasting lots of time. That is one. Second biggest problem is the speed. 1 second, 1 second. That is fine, but you cannot do it now. 1 second is very, very slow. So what happened? People have designed a device. People have designed a device. That device will on the switch. See that, not manually. That device will electronic switch. If we give you 0 volt and 5 volt, it will on the switch faster. Okay. This signal is going to be on and off. It's called clock. And this device is called clock generator. So what is happening is, clock generator is the one which will give the timing. I told you 1 second timing agreement. Okay, now I can have 1 second to 1 millisecond. Then I can transfer data faster. If we do 1 millisecond to 1 microsecond, I can transfer faster. But the problem is, this guy is having a separate clock generator and this guy is having a separate clock generator. And this is giving a clock here. Because of the two clocks, this guy could be doing 1 kilohertz. That is 1 milliseconds. Okay. And this guy could be also 1 kilohertz, 1 millisecond. But unfortunately, as I told you, due to the electronics or due to the mechanical components, due to the heat, due to environment, one could be a hot place, one could be at the cold place. Okay, somewhere the 1 kilohertz could go to 1.1 kilohertz. This 1 kilohertz can go to 0.9 kilohertz. There could be a small difference. Like I told you, the speed could not be so perfect. In that case, what I transmit, what I receive may not be correct. So, industry, there were two problems faced by the industry, this method. There are two problems faced. One problem, what they faced is wastage. That is for transmitting 7 bits. I transmit start, check, and stop. 10 bits. I waste 3 bits. For 7 bit, I waste 3 bits. It's almost off. Okay. That is, you buy a item for 10 rupees and you spend 10 rupees for shipping. That's not that you don't like it. The same thing now. Okay, to transmit 7 bit, I have to waste so many bits. Second one is clock. The clock case, they face bigger problem. The problem is when I start increasing the clock, when I start increasing the speed, that is from 1 kilohertz to 1 megahertz, then the drift had become too much. Okay, then they were not able to transmit properly. So finally, the industry has come to the method. You do, man, if you have a timing, if I have a timing, there is a confusion. So let me not have the timing. Let you keep it. So what happened? Whether it's a 1 second or 2 seconds or 4 seconds, I don't bother. Who don't bother? B. So what they have done was between A and B, there's a wire. There's a wire where you on the switch. That will become bulb is on. But this man will not accept the bulb. Whether it's on or off, he does not bother. There is one more switch. There's one more switch. What our man will do, he'll be watching this bulb. So there are 2 bulbs. Previously, what happened? We discussed only 1 bulb. Now we are discussing about 2 bulbs. The second bulb, where this man, when I on the switch, this guy will not watch this bulb, he'll be watching this bulb. So what the person A will do, when I want to transmit 1, I will on the switch. Now this become 1, but this guy is not accepting. You know when he will accept? When I on the switch. When this wire is becoming 0 to 1. When this wire is becoming 0 to 1, then this guy will accept the data. I need 2 wires. Okay. So one drawback here is we have 2 wires, but one advantage here is this guy speed is does not bother. The speed is controlled by me. This we will discuss tomorrow. Okay, this we will discuss tomorrow. This is a very, very critical. This is, if you understand this, you understand not only the networking, it goes to everywhere. All your, whether you want to have understand USB or SPI or I2C, all this kind of PCI Express, everywhere this is what the bottom level. The bottom level is because there are only, how I told you that simplex and duplex. Okay. And duplex, we have a off duplex and full duplex. Like that. In communication, there are 2 types. One is called asynchronous. Other one is called synchronous. Only UART. Only UART is the only device called asynchronous. All the other, that's why they call this a universal asynchronous receiver and transmitter. That's called full duplex. I can do receive and transmit simultaneously. This says full duplex, and it's a universal because worldwide is agreed. I'll tell you why the word is universal. And A is called asynchronous. Okay, but this communication, adding one extra wire, they call this wire as a clock. This is data. This communication is called synchronous communication. So we have 2 types of communication in the networking. One is asynchronous, one is synchronous, where we use synchronous. Tomorrow, we will discuss little about the synchronous, then we move on to the what type of networks. Then you will understand why I explained this today. Okay, this synchronous, I'll explain tomorrow a little bit, then I will discuss about networking. Okay, with that, let me do the formal closing of today's lecture. And we'll discuss. We'll not leave